Let's go to this dir attribute VOP, and let's maybe drop the roughness just a little bit, so maybe not have such a strong noise to it. Alright, so maybe let's just set this at 0.6. So what I want to do with this vector now is I want to sort of spread these vectors along the path that the lining creates. So if we can imagine that a lining, one of these linings might start here and they go outwards along a line over here, I want most of these pieces to go on this side of the lining and the other side of the pieces to go on the other side. So we want to sort of influence this direction a little bit. We can go ahead and let's go to where we created these curves from the simulation points. Okay, and I will grab this, Control C, and let's go ahead and drop down an object merge here and import them over to our vector network. Okay, so these curves I will place in the second input for my attribute VOP that's responsible for our direction. And let's step inside and see what we can do here. Let's grab this geometry VOP and let's drag this over here by holding Alt, so we can duplicate this. And we can access our curves from this op input 2 dot over here. And from here I will drop down an XYZ distance. And I will set the pose to look at our P, so this will now look at the position of each point. And let's place this prim inside a primitive attribute. And if you want to learn more about XYZ dist and PrimUV, there is a free lesson in my previous course that explains this in depth, and also I uploaded that lesson on my YouTube channel. So that lesson explains how these nodes operate more in depth and exactly what they do. So you can find the link to that video in the links file that I included with the downloads, so you can check that out. But essentially what this is doing with this XYZ dist node, we are making our points look at the surface of the geometry, which in this case is our curves. So we will look at the surface of our curves and we will grab an attribute from the closest position of that curve. And in this case we want to grab the P attribute, so in our PrimUV we will type here attribute P, and I also want to plug our PrimUV inside the UV as well. So from our position of the points we can drop down a subtract, and if I subtract this value here from the PrimUV, and I can visualize this vector if I just place this inside our bind node, we can see that this is the vector that we get. So this isn't looking right, and that's because we forgot to set the file for our PrimUV to also look at our curves. And let's go ahead and also make this vector flat on the y-axis. So after the subtract I want to drop down a multiply and promote this to a constant, and this will be a 3 float constants, which is 1, 0 and 1. So we don't have any amplitude on the y-axis. And we will also normalize this vector as well. So drop down a normalize after the multiply. So now we can use this vector in our original vector that we created first. So after this multiply over here, let's actually maybe make some room. So this amplitude and the multiply is the last thing that should happen in this dir attribute. So let's place this here. So after our normalize, let's drop an add, and just make sure that this add node is before the multiply with the amp. And let's place our new vector inside our add node and see what happens. Alright, so we can see that the vector is starting to split along the position where our lightning will hit. So if I turn this on and off, we can see what this vector will do now. I also maybe want to, let's maybe just make some room over here from here and drop down a multiply as well. So I want to scale the influence this new vector has on our original vector, and I will promote this parameter here, and we will rename this label to spread amp or spread add. Okay, so if I go up a level and increase the spread add value, we can see that we exactly control how much we want this to influence. I also want to scale this vector as it goes outwards and away from our lining. And inside my VOP, this XYZ dist also creates a distance from each point of our geometry and where it lands on the curve. So I can place this inside a fit. So I will place this over here where we also multiply it with our custom parameter. Okay, so if I place this here, let's maybe adjust some of these settings. So maybe I want the distance to, I want to increase the distance a little bit. So let's increase the source max, and we have to reverse these values here. So I will set this to be 1 and 0. And we can see how this effect will look maybe if I set this to a value close to 0, so we can further control how the spread angle will affect our final vector. So maybe just increase the source max value, and maybe the source min as well, and let's go up, and I will decrease the spread angle a little bit. Okay, so now our pieces should start flying in opposite directions of the lightning, the closer they are to the lightning itself. And let's take a look at the animation, and this should be fine. So now if I go to my .NET simulation, let's see how this will look. And let's play the animation. Okay, so now we are sort of starting to get the result that we are looking for. Now this, obviously the amplitude is a little bit too high, so if I were to just step inside here, let's set the amplitude maybe to a value of 25. And let's maybe preview this. Okay, so this is maybe a little bit better, but there are still some problems that we need to deal with. And we can see that the force is maybe not high enough to create to move all of the pieces that we want. And also when we first play the simulation, we can see that some of these pieces are moving over here, which is because they are being affected by the gravity and the collisions. So in the next lesson we will set up an active attribute which will basically tell the pieces exactly when they should start moving.